Okay, good night, everyone. Let me know if you're hearing me in the chat. Let me know if you're hearing me in the chat. All right. Hi, Michael. Welcome back. Hi, Rosewell. All right. Very good. Very good. Joel, share the live with the others. All right. So I had a copy of this paper, and somehow I am unable to find it. I have to be doing screenshots of the question and we post it here for better manipulation basically. The PDF document that I have, it is um, the orientation is different, so I can't use it. So I'll be snipping and pasting as it is that we go along so that we can work the questions. So this is the June 2022 paper 2 paper. But before I get into that, how was paper 1? How was paper 1 for you guys? I don't think paper 1 was bad. How was paper 1? Not seeing any response. All right. Thank you. Smith, Dell, thank you. Was decent. Most of the questions came back, I think. I think most of the questions came back based on reports. It was new. Oh, that is a new aspect of the syllabus. You would have looked at that when it is that you are looking on algorithm writing and the different process, top down, bottom up procedure, basically. Okay, Bree. You completed the paper and then went to sleep. Cry, why? Okay, Bree. You didn't do that bad, Smith. You're good. I'm sure you didn't do that bad. All right, let's get in to this paper so that I can have you guys getting some rest. All right. Excuse this. Let me see if I can redo it and change this image because it's very blurry. I remember that you probably have to change the quality of your output if it is that you're seeing it blurry on your screen. So last year, the first question, question one, says using logic gates, draw a clearly labeled diagram of the SR flip-flop. So when it is that, oh Lord, I'm going to try and draw it using this. Once it is that we're drawing a flip-flop, right, we're going to draw two AND gates first. No, I don't want that. Right. So you draw two AND gates. After you draw the two AND gates, I want you to draw two lines going to each AND gate. And we connect these two lines together. This is going to be your clock. This is your set, and this is your reset. I'll just write CLK here. All right. Then now, from each AND gate, we draw two lines. And then for each line, we're going to add an OR gate. So that's two OR gates. So we go like this, we go like this, and we go like that. That's our OR gate. So now, so go like this, go like this. All right, OR gate. So going into your OR gate, you should have two lines. Let me erase this one, so I want it to be better positioned. So we're going to have two lines. So we're going to go in from the top for each. From the top one, we're going to go from the top. For the bottom one, we're going to connect it with the bottom one. Right? Then now, we're going to have our output lines from each. And this is where we're going to cross. So from the set OR gate, we're going to draw one line coming down and basically connecting with this line. Same thing with this one, we're going to have a line and crossing with this one. And for your output, once you have one positive, you must have one negative. So you can have Q, you can use F, you can use, yeah, any variable basically. So if you have Q here, it means that at this point, you must have negate, which is opposite. And you just put an apostrophe or you draw a line on top of it. And that would be your SR latch. This is the SR latch. The difference, I'm going to show you a drawing for the JK. The JK feeds back into the, so while it is for each AND gate here, we're only showing two inputs, which is the clock for each, the clock and set or the clock and reset. For your JK, it goes back into from output. Hope that makes sense to you. So this is the SR latch for this question. Flip-flop, sorry. What would your JK latch look like? So not a part of the question, but let's say for instance you get the JK latch, we're going to do the same thing. Draw your SR latch. Now, your SR, your set reset flip flop, it has drawbacks, it has disadvantages. And those disadvantages were addressed using the JK latch. So your JK latch is that of the SR latch, but an advanced version. And the JK basically just stands for the person who created the latch. So same thing we are going to do now. We'll draw back our AND gates. So we have two AND gates. Right? And we're going to have two lines again. Connect these two lines that are beside each other, right? And that is going to be your clock. Coming from each AND gate, you're going to draw now your OR gate. And my OR drawing may not be as pretty as yours when you're drawing it. So excuse the butchering of the gate. We do the same thing. We have one line going in here, and we have one line going in here. Now we're going to cross just like we did before. So we're going to have this one coming down. Have this one. I'm basically touching right here. And I'm going to make a dot right here because it's important. Same thing. And we cross. Right. So now the difference now. So this would be your J input. This would be your K input. Now your JK latch has basically a way of feeding back data in while it is in waiting. So all you would do is show that this comes back into here. And that's the JK. So for the JK, you have three inputs, right? Same SR latch that you're going to draw. Have three inputs. So you have the clock, you have J, you have K, and basically where it is that if the output, sorry, is in waiting or reserve, basically feeds it back in until it waits for it. So you would have to label your output again. So that is Q negate and Q. And that's your JK latch. Any questions? Uh, Supposed to be not gates. For what is supposed to be the not gate? The NAND gate. It depends on what they're marking for. This, this is my method. See, sorry, left out right here. So that's it for that one. See, so I'm in the application, I'm not seeing the questions as they come in. What would the truth table for a JK latch look like? Your truth table for a JK latch. So you're only going to get, so when J and K are at 0, you get a positive, right? So you have 0, 0, giving you just a regular output. So when the inputs are the same, you would get the inverse. When it is that J is at 0 and K is at 1, then your output is going to be 0. And the reverse, when it is that J is at 1 and K is at 0, you're going to get 1. It is. It is. I'm really hoping that they don't ask anything for the truth table for these, because this year was a rough year. All right, let's move on. This was a pretty easy paper, so I'm not sure if 6 you want to keep it easy this year, but that would be a very good thing. So it says construct the truth table for the following circuit, which is a combination of basic logic gates. Now, first you have to analyze. For this combinational circuit, we have two inputs. Now, that's the first thing you're going to do. 2 to the power of n. N represents the number of inputs, and in this case, we have 2. So that is 2 to the power of 2, which is going to be equal to 4, which means that our truth table is going to have 4 rows outside of the heading. All right, no questions. So, all right, good. So let me continue now. So we look and we create a table. Let me see if I can insert into table. Oh, it's already on. So good. All right. So for our first column, we're going to have A. We're going to have B. And as I said, outside of our heading, we're going to have, Jesus, we're going to have 4 rows. When I want this thing to straighten my lines, it doesn't. All right. So we can start now. So under A, we're going to take 4 and divide it by 2, which means that we're going to have 2 ones followed by 2 zeros, or we're going to have 2 zeros followed by 2 ones. So that I prefer starting with the 1. So that is now 1, 1, 0, 0. Hopefully that was clear. So the number of inputs will determine how many rows you have, and then you divide that by 2, and you basically start out with that. So if we had 8, we would have 4 ones and then 4 zeros. If we had 16, then we would have 8 ones and then 8 zeros, right? Then for B, B, you're going to alternate. So whatever you have here, you alternate. So that is now 1, oops, 1, 0, 1, 0. Any questions thus far? Any questions? All right, no questions. All right. So now we're going to look at our gate or combinational circuit, sorry. And that will determine what our next step is. So here we have A, and we see that A is going through a NOT gate. So whatever A is, we need to have the opposite of that. So it's A negate. So I'm going to have A and put my apostrophe, which means opposite or not. So whatever A is not. So I'm going to have the opposite of A now. So I'm going to have 0, 0, 1, 1. That's A negate. So this triangle, negate. All right. I cannot draw a straight line to save my life. All right. This gate now is an OR gate, right? And we're seeing where A and B is going through an OR gate. So basically, we're going to add. So it is here, it is A plus B. Right? So only when it is that we have two zeros, we're going to get back a 0. Once it is that we have two ones, it's going to be equal to a 1. So 1 plus 1 is going to give us 1. 1 and 0 is going to give us 1. 0 and 1 is going to give us 1. And 0 and 0 will give us 0. So we've covered this and we've covered this. So now we need to look now. So we have A, not A, right, going through an AND gate. And we also have A and B. So we have A and A or B going through an AND gate right here. So how does that equation look? So it is not A. That's the first thing. So let me write this. Not A. Right? Going through an AND gate. And AND is our multiplication sign. And we have A plus B. We're going to do that first. There's something else that I need to show you, but we're going to do this first, just to make the whole process easier. All right. So we're going to use these two, the blue and the green, and we're basically going to multiply. Wherever there's a 0, we're going to get back a 0. If we have two ones, then we get a 1. So only when both inputs are high, then we get back a high. If we have one input being high and one being low, we're going to get a low. Right? So let's do that now. So 0 and 1 is going to give you 0. 0 and 1 is going to give you 0. 1 and 1 will give you 1, and 1 and 0 will give you. But it's important to note that there's a dot at E, which means negate. So this now that we have here, A, not A, multiplied by A plus B, this dot means that we should have the opposite of that. So I'm going to put that right here. As I say, I have a shortened way of writing this. I prefer the longer route so that you ensure that you get the maximum marks. So it's not A, right? And then I'm going to have A plus B, and I'm going to bracket that. I'm going to bracket all of that and have a not right here, which means opposite. Hope you guys are following, or my explanation and my explanations are clear. So we're just going to do the opposite of this. So we're going to now get 1, 1. This is 1, so opposite would be 0. This is 0, so the opposite would be 1. Still not finished. The final part right here is where we're seeing this equation along with A plus B going through an XOR gate, and that now will give you your final output. Equation. Let me see if I can get this line straight. If you're typing in the chat, I'll soon come to your questions. All right. So we're going to take here A or B is going through our next OR gate. So let's bracket that off now. So it's A plus B bracket that off, right? And it's going through an OR gate. The OR gate is a plus sign, right? And we're going to write back this equation because that is this gate. So the results of this gate is going through the OR gate, which is this one. So bracket right here. So I have A. So if I say a line at the top, it's the same thing. Do the opposite of whatever A is. A plus. And we're negating this part. We draw this line, this line. So what is your final output now? Let's hear in the chat, what's your final output? You're not hearing me? All right. So Smith's question. Let me go back through now with questions. All right, Smith. Wait, Miss. Why is the initial A not 0011 and B being 0101? All right. So this question now, let me pin it on the screen. That's what I was saying in the beginning. You can choose whether you want to start with zeros or you want to start with one, but you have to remain consistent. So if it is that you start the first column with 0, you must start the second variable or input with 0 as well. So you could have it being 0011 and you could have B being 0101. It would be the same thing. It would basically yield the same output in the end. It's just that your response would be reversed. So where it is that A negate I have 0011, you would have 1100. But the output, the overall output would be the same. All right, next question here. It says, and when A passed through the not, it changes to 11. Right, so if you're seeing now, for this question that's on the the screen, if you realize that when you start with the 0, your response will be the opposite of mine, because you started with 0 and I started with 1. So if you look at A negate, you will see that I have 0011, and in reverse it is 1100. Why not use the letters, as in the letters for and or the letters for or? Bucky. All right. All right. So I'm seeing the answer. So the answers indeed is 111. So let's show for the other one. So we say, so let me just tick the error. So I'm using this output and I'm using this output, right? And we're adding them together. So once it is that we see a high, we're going to get back a high because we're adding. So 1 and 1 will give you back a 1. 1 and 1 will give you back a 1 again. 1 and 0, because we have one high, is going to give you back 1. And we have a low, but we have a high here, so we're going to get back 1. Write it differently so that it doesn't look like we're joining. So that's 1, 1, 1, 1. All right, very good. All right, A, B, C, D. Oh, I don't practice that, Bucky. I don't practice that, but it could have been used really and truly. Looking on the diagram, yeah, you could have used that. So based on what Bucky is saying now, let me just show you. Instead of having A negate, he's saying that could have had C right here. I wrote these. And D now, which is right here. So this would be D, this would be E, and this would be Z. Except that if for the other persons who are probably confused, hopefully this will help. So C was this one, the results coming out, which would be not A. D would be A plus B. And E, as we would have explained, is A, the results of here, and the negate here. And Z would be the final output. All right, Bucky. All right. Let's move on. So that was question 1B. So I'm fetching the next question. All right, part C now. So we know that hexadecimal is the base 16 number system, right? If you're given a base 10 number to convert to hexadecimal, then you divide by 16, right? The hexadecimal system, it uses A to F as well as the digits 0 to 9 to make up the 16. So if you get a remainder of 10, that would be A, 11 would be B, 12 would be C, D would be 13, E would be 14, and F would be 15. So please remember that once it is that you're converting and you divide, once you get those remainders, those values as remainders, you use letters instead of numbers. All right. Now, in this question, which is CI, we have two ways of representing this. We have two ways of coming up with the solution. What's the shortened version? That's the one that we're going to do first. So A, A in hexadecimal is equal to 10. What is the binary for 10? Drop it in the chat. What's the binary for 10? What is the binary representation for 10? Divide 10 by 2. What is the binary representation? All right. Smith is oath with her response. Very good. No, Patterson. That one is Buckley. Your response is Patterson. Right. So one. Oh, let me use a different color. 1 0 1 0. All right. So next question now. What is 9 equal to in binary? I hope you don't make that mistake in exam, Patterson. What is 9 in binary? Divide 9 by 2, noting the remainder. All right, Patterson and Smith. Very good. So 9 now would be equal to 1 0 0 1. And then we combine it. So the binary number for this would be 1 0 1 0 1 0 0 1. I'll put our base on it for base 2. And that's the shortened version. Long version. We have 2 digits here and we use the power table. So we have 16 to the power of 0, 16 to the power of 1. And I'm showing you this way just in case this is what will resonate with you or this is what you were taught. But because of how complex section C can be, I prefer if you use less time on section 1 and 2. So go through. All right. 16 to the power of 0 would be equal to 1, and 16 to the power of 1 would be 16. Write in our values and multiply those. So we say A is equal to 10, and then we have 9. So we have 10 times 160, which is going to give 10 times 16, which is 160, plus 1 times 9, which is 9, is now going to give you 169. All right. Then now, we need to convert 169 to binary. So let's go with the long version. So we're going to take 169 and divide it by 2. And you realize shortly that we'll get the same answer. So 2 into 16 is going to be 8. 2 into 9 is 4 with a remainder of 1. 2 into 84 is going to give you 42 with a remainder of 0. 2 into 42 is going to give you 21 with a remainder of 0. 2 into 21 is going to give you 10 with a remainder of 1. 2010 is going to give you 5 with a remainder of 0. 25 will give you 2 with a remainder of 1. 22 will go 1 with a remainder of 0, and we bring this over and we get 1. Writing now from bottom to top, you'll get the same thing. 1, 0, 1, 0, 1, 0, 0, 1. So the option is yours if you want to go the long route or you want to go the shortened route. It is longer. Who is Dukington? Dukington. Hi, Dukington. It is a longer method. But you know, some methods resonate with some people, so I just showing. All right, so let's go back to the question at hand. All right. So the next statement that your answer C is a 2's complement binary number, convert it to decimal. All right. So when we're converting a negative to positive, you cannot convert it using 2's complement. You would change it to binary and as is. Right. So once it is that we're moving from binary to 2's complement 1, which once we're changing it from decimal to 2's complement, we convert the decimal number to binary, make it up to the required number of bits. So if they tell you 8, if they tell you 6, whatever it may be, then you're going to flip the bits, which is to find the ones complement. So wherever you have a 1, you change that for a 0. Wherever you have a 0, you change that for a 1. Flipping the bits. To the ones complement, which is the flipped bits, you're going to add 1, and that will give you the 2's complement representation. So what this question is asking is for us to do the reverse of that. So the last step in the 2's complement is to add 1. So now we need to subtract 1. So we're going to write this back. So that is 1, 0, 1, 0, 1, 0, 0, 1. All right, and we subtract 1 from this. So 1 from that is going to give you 0. Then we have right back everything else that's here, because there's no other calculation that needs to be done. So we added 1 when we were moving to 2's complement. Now we're moving from. So after we added the 1, we're now going to, well, we subtract the 1 in this case. Now we're going to flip the bits, basically, or unflip the bits in this case. So wherever I have a 1, we're going to change that to 0, and wherever we have a 0, we're going to change that to 1. So that now, let's write that in a different color. So this is going to be 0, 1, 0, 1, 0, 1, 1, 1. So after we've done that now, this number we need to convert. Who can tell me what is the answer for this? I know, right? Well, 3 marks for this one. What does this equal to? So use the powers table. So come back to the comments. So now I have 1, 2, 3, 4, 5, 6, 7, 7 bits. So I'm going to use my powers table. And there are shorter ways that you can do this, but powers table, because I don't want anybody to ask me how it is that I got anything. So it would be 2 starting from the right, 2 to the power of 0, and we're stopping at 8 because we have 7. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Alright, what does this equal to? What is the value? This is 1, this is 2, 4, 8, 16, 32, 64, and 128. And I don't need to use the next one. And I write the values in. So that would be 1, 0, 1, 0, 1, 1. Hold on. So that is 1, 1, 1, 0, 1, 0, 1. Did I leave out a digit here? 0, 1, 0, 1. Okay. Alright, add this up to me what you get now. 87. So that is 64 plus 16 plus 4 plus 2 plus 1. Alright. That's del. What's the value? Minus. Alright, so 64 plus 16, 6 and 4 is 10, carry 1, 6 and 1 is 7, and that's 8, so that's 80. Alright, 80 plus 7, 87 is the answer. Alright. And that would have given you 5 marks. So let me get the next question. So that would have been it for question 1. And we're now going to start question 2. What would have been your mark if it is that you were doing this paper? Would you have gotten all marks? All right. So the first part of this question says, define the term cache memory. 2 key terms that I'm looking for, right? That's in the chat. I'll try, Jaden. High speed. All right, Darren, I like that. High speed memory location near the CPU. All right, that is one, Darren. So you're going to tell me high speed, all right? But I also need to know what it stores. What does it store? Frequently and frequent. No, not frequently stored. What does it store? Frequently, I'll take from Smith. High speed memory location. High speed memory location used to store more frequently. Not date, but data. Ah, right. So that is it. High speed memory location used to store frequently used data and or instructions. And we good with that one. All right, next part. Explain how cache memory increases the efficiency of data retrieved in the CPU. So that was basically stated in the answer before. Good. Because of its location, it is located closer to the CPU than RAM. So because it is located closer, it means that fetching the data is done at a faster rate, right? So that is part of the explanation. Based on its location, fetching data would be much faster, which means that the entire processing speed for you to execute a task would not be as long, even though we know that things are processed very fast. Ready to use as well. All right. The next thing now is because of what it stores. So it stores frequently used data. Good. It means now that additional resources would not be allocated to complete specific task or that task that you would have stored in cache. So I don't need to take resource from one process that is taking place to or free up that resource, right, to complete a next task for something that's frequently being used. All of that information is stored in cache memory, so therefore it doesn't need the same kind of resources. And that would have given you your 3 marks. Any questions here? All right, moving on. The next part B says name two components of the CPU other than registers. What are two components? All right, thank you, Smith. What are two components of the CPU other than registers? It amazes me that people fail this paper because this paper is very easy. Ah, very good. So ball of flames came in first. ALU and CU. Then we have Darren. Then we have Black Cobra. ALU and CU, arithmetic and logic unit, and the control unit. All right. Then it says now to state the function of each of the components used above. Right. So your arithmetic and logic unit, what is that used for? What is the ALU used for? What is the control unit used for? Mathematics, Darren. So the ALU is used to perform all arithmetic and logic operations. What was the mark here? 2 marks. So that would have given you 1 mark for ALU. The control unit, boy, say tomorrow, I'm not so sure. I'm not sure. When I looked at this paper, I was like, boy, 1-6, I could try something, but you can only hope. Alright, CU is used to fetch the instructions from memory and decode it. The CU manages all instructions coming in to the CPU, directs the flow of information or data. Alright. Same thing as that Lookington. It is going to fetch the instructions, and by decoding it, it's going to identify what is needed, where it should go, etc. All right. All right. So let me fetch the next part of this question. All right. So briefly describe a scenario in which each of the following types of computer can be used. Supercomputers. That was correct. No, no, Smith. Nobody think about that. Anything sexy come and throw at us tomorrow, we are going to do well at it. That's the mindset that we're going to have. That's the mindset we're going in with. Weather forecasting, right, Christian? Very good. And you'll provide some explanation on that. Exploration, all right? I'll take that as well. Exploration simulations. And you explain that for 2 marks. So weather forecasting, the trajectory for or the path that a storm would take, the wind speed, the basic details pertaining to the weather, right? What would they, based on whatever they use. I don't know what they use for weather forecasting, so I'm just guessing here. What would be the prediction for the next couple of days? Are we expected to get rainfalls? All of these things. If a hurricane is coming, they can use that to basically present information to us on whatever storm it is, earthquake, hurricane, all of that, right? Exploration. Think about scientific research, right? So if we're going on the moon, what is needed? It can be used to do all of those kind of calculations. If you have a car, and you're driving at X speed and you slam into a wall, what is going to happen? What are the effects? So it can simulate all of that. For persons who are learning to be pilots, right? It's not like a car where it is that you can say, all right, come, press the brake, press the gas, shadow the brake and all these things. No. You have to go through simulations first before it is that you are able to go into the and do the real thing. All right, so that is it for supercomputer. The next one is server, same thing as your mainframe system. All right, scenarios now for server. Vroom, vroom. Can you imagine here that your pilot is testing out the aircraft today? Is that true, Oh, servers are mainframes. What's the scenario for those? Once you hear server, one thing should come to mind, always come to mind. Think about multi-user systems, multi-user, multi-processing, because multiple persons are using it at the same time. So think of any industry, any organization that would require persons to be able to access their system at the same time without, right? All right. I say Lano with gaming. All right. And I see Smith as well with gaming, with games. All right, gaming, that's one. Anybody else? The banking industry. Yes. What you think allows persons in different areas. So I am in Jamaica, somebody else is in Trinidad, somebody else is in the United States. It is because your information, the server allows, basically. As I said, when you think about server, think about mainframe systems. So it is one gaming hub, but with the hub, it allows multiple persons to access it from different places. So it would just like your online platform for banking. I can be in the US, but I want to log into my information here. So all of that is saved on a central server for you to access. Clear, TD? All right, good. So I said we say gaming, we say banking. Even with you creating like a website and having your information out there for the public to access, it is saved on a server somewhere. It is served on a server somewhere. So basically, those are scenarios that you can use. Watch here, I mean, hear my voice, but thank you. All right. And the last one says mobile device. I think mobile device by far. Thank you. Mobile device would be the easiest one. That would be nice. Um, the easiest one. When do you use mobile devices? To keep in contact with persons from anywhere, any and everywhere. Persons use mobile devices. And when you think about mobile devices, I just don't want you guys to think about cell phones. Remember that mobile devices are laptops as well, right? It involves tablets, it involves cell phone, tablets, and laptops. So, what is it that you're using that to do? So, you're using it to create documents, you're using that to join meetings, you're using it to log on to your online platforms, you're using it to check your CXC grades. It is a lot of things that you can do with mobile device. I think that one was a pretty. Let me tell you some things. I looked at this paper so many different times, but yes, it is. I looked at the paper so many different times. I was even trying to figure out which question it is that I marked because I know I'm not seeing it. I don't know. I looked at the paper and I was wondering, hold on there. When I saw end of test, I was like, no man, wait, something not right. That's why I said it at one point. Like I really don't understand how persons fail this paper. I mean that they will go in there and them never prepare. All right, that's it for question 2, and we're now going to move on to question 3. All right, so guys, kindly note for the most part, well, for section 1, you have a lot of information that they can draw from there because the bulk of the syllabus is at section 1. I would think it's a lot of notes. However, I don't understand. 1 minute, guys. However, section C can be very, very tricky. So my advice, and my students will attest, this is what I've always said: use the time to basically go through, become comfortable with the content for section 1 and section 2, especially section B. when I tell you that if you go through any past paper, more than likely you already know what is going to come for section B. So maximize. Go through, run through section A, run through section B, and then use the time now to answer the questions in section C, because that one, this year it was very straightforward, but in previous years, not so much. All right. So list three properties of a well-designed algorithm. If you're doing computer science and you cannot answer this question, you know, and I think files come in this year, Nadel, because when I looked at this paper, it was structures and functions predominantly, and I think files will come, whether or not they give you files and functions or files and structures. I really don't know, but I think files more than likely is going to come. Bucky, you can do files, and I don't know why it is that you're over there talking about you pray that files won't come. All right, let's go through this. Property of it is just seeing Smith own. Unambiguous finite steps, logical sequence. All right, take that deal. Next one, ambiguous and clear. Unambiguous finite steps and must produce a solution, Smith. That is what I would add to yours. Right. It must produce the correct solution, not just a solution, but the correct solution. So unambiguous, we have clear, we have finite steps, must produce an output, right? Must have an end, that is one as well. So you just don't have your algorithm running from now until the Lord says when. It must have a start and it must have a stop. All right. Moving on. So the next one is a flowchart question. Fetching the question. And this, I think, as well was a pretty easy question for flowchart. All right, so I really don't think that they give me the shape in this application. So let me see what I can muster up. So start, shape for start and stop is an oval. All right. And then your diagrams, they must be labeled. So if you don't have anything in there, you're not going to get the maximum marks. All right. Right. From each shape, you must have your arrows. So it's not just lines. Your arrows must have some form of head on them. All right. So we've done start. Then it says print, enter A, and read A. That is one diagram, so you don't need to break it up. Remember, we tell you about time. So if you put print A, read A, all of that is fine. And we use the parallelogram, aka the lean rectangle, to for that one. All right, good. So the system knows what I'm writing, and we're going to have, for me, I'm just going to have read A. Arrow again. So that is this part. So we have total equal 1, and that now is going to be rectangle. All right. And in our rectangle, we're basically doing our assignment. So total equal 1. All right. And we have our arrow again. So now we're going into while. So if you have a while, if you have a if you have a for, if you have a repeat until, all of those must be represented in using a diamond. All right. In our diamond now, we're going to put the same thing, or you can write it as a question. Is A less than -1? Or you write it back as is. So I'm going to have while A, how do I resize in this now? A is, sorry, greater than -1. All right, hopefully this fits here. Let's see if I can get this bigger. All right. All right. So you get marks for the shape, you get marks for labeling the shape. Now from your diamond, you're going to have 2 lines, and you must label your lines. So you must label the lines true, you must label your lines false. Guys, if you're typing in the chat, I soon come to it because I'm in a different application. So we have while A is greater than -1. So we want to know now, is A greater than -1? Right? So if A is greater than -1, that means that it is true and it should come this side. If not, it is false and it should come to this side. False means that we're going to go outside of the while. True means that we're going to do what is inside of the loop. Right? So that's our while. Then we have A equal 2 times A. And that's an assignment. So we are going to use a rectangle for that. All right. So now we're going to have here A equal A times 2. And that is that. Then after that now, we have a next diamond because we have an if statement here. So let me draw my diamond. All right, very good. And in my diamond again, as I said, you can write your question or you can basically type back what is there. And that's what I'm going to do. So if A is greater than 20, and we don't need to write the then. All right. So the same thing that we did for the while statement is the same thing that we'll do for the if. You have 2 lines and you must label true and you must label false. So this is true, that is false, sorry, and this is true. So if A is less than 20, it is saying that A is equal to A minus 1. Otherwise, A is equal to A plus 1. So those are calculations, and we put them on the true side. Well, the minus is going to go on the, okay. me try and draw this neater so I can get it to adjust to the shape. Alright, very good. No? Alright, it's not giving me that one. Alright, so let us type now. So I have A equal A minus 1. And that goes on the side for true. So if A is less than 20, then we should subtract 1 from A. But if it is greater than, we should add 1. So we're going to now have A equal A plus 1. And that would go here. Now, because of after this now, we have an end if, we basically need to merge these two. So we draw a line, sorry. And we're going to use what we call connectors here, which is just a small circle. All right, so from your connector, so we did the if statement, we did the while. So after end if, we're seeing where it says total equal total plus A. So we need to show that right after this connector right here. So your connector is going to act now as your end if. For calculations, we use rectangle again. And you must label the rectangle. Total equal total plus A. I'm going to try and expand this. All right. So here's this part now. We have read A. Now notice now that this is a loop. So we need to show that aspect that it is a loop. So what we're going to do is right here, we're going to have this parallelogram which says read A. Right. Then now we need to show how it is that it loops. So we're now going to draw a line. All right, hold on. Hope you guys are seeing this. We're going to draw a line coming from read A. And we need to go right back up to the while statement right here. So that should be a straight line on your part. And it should have an arrow at the end here. Please excuse my awful drawing. So that would show the loop, and that's your end while. Now, after end while here, it's saying print total, and then you have stop. That is going to come from false, because now the condition is outside of the realm. So A is now less than -1 or equal to -1. So now we're going to print. Print is the parallelogram as well. And coming from print, we're also going to have stop, which is our oval. So let me add the text. Stop. Comes here. And then now print total comes in the next one. So of course, again, yours would be a neater version, but that in essence would be your flowchart. All right, let's hear the questions. Nice and straight. I cannot draw a straight line to save my life. And that was 12 marks. All right, very good, Smith. I like that. So that would have given you 12 marks for that question. Your help will be appreciated. All right, so we can move on to question 4. That was question 3. Question 3 had two parts, A and B, and question 4 no. All right, that's for A and for B. 6 and 2, 8 marks here. So 4A says briefly describe 3 stages in the software development cycle. Now that was an error, and anybody who has the paper will see the correction that CXC sent. So the question should actually be briefly describe any 3 stages in the problem solving process. That was it. So not software development, because that is actually unit 2, not unit 1. But this question, it was asking for problem solving process. Now, the stages in the problem solving process, I'm talking now. Are you hearing me, Smith? Don't pay them no mind. All right, Smith, hearing me now? All right. Stages in the problem solving process. Now, we have to identify the problem. So we have to understand what is the problem at hand. Because if you don't know what is the problem at hand, you can't solve the problem, right? The next thing, you want to analyze the problem. In analyzing the problem, you're going to do your necessary breakdown. What inputs are required, what processing will take place, what output, what will be stored, right? Then you want to identify possible solutions. So there's no one way to solve a problem, but what's the most efficient way? So after you've identified that I can go route A, route B, route C, which is going to get me there efficiently, not using up much resources, etc. All right. Then now you want to represent the solution in a using an algorithm. So we're now going to write an algorithm which is going to represent the solution. After you've written your algorithm, you want to test it. You want to test the solution, ensure that there are no errors, right? And if there are errors, address those errors. And before it is that you move into the next stage, which is basically to represent the algorithm in a particular language. Then now you want to document and documentation and implementation. And any of those descriptions would work. Right. Justify the solution. All right. I missed the parallelogram with assignment statements. So any prompt, anywhere it is that you're asking to the user to enter your outputting, try remember that part. Lean rectangle. All right, problem definition, problem analysis, test and evaluate solutions. All right, I can work with that as well. Implementation and review. Dukinton is adding to Bear Rabbit response. Ah, all right, good. All right, so the next part of the question now says define the following control structures, giving one example of each. What's a selection statement? Justify solutions. Evaluate solutions should be justified. All right. Selection statement, what is that? When you hear of selection, what comes to mind? Based on criteria. All right, bear a bit. Selection is when a program chooses a condition when a criteria is met. Not a condition, instructions, Smith. So it basically executes instructions based on the criteria. So if statement, so any of these two with just the minor correction to the end part of Smith own would work, and you would basically just write the if statement. That's for your selection construct. The next part of the question now, which is the next part asks for iteration. Let me get the question. So I have to be snipping the question and then pasting it here. All right. So the next part, as I said, was iteration. So iteration now is control structure that repeats for a specific amount of time or an unspecified amount of time based on a particular criteria. And for this now, the example that you would write would be for or repeat until or while do while. But for your syllabus, for while repeat until. All right, C was also pretty easy. I said this paper was very, very, very easy. All right, so look now on this question and tell me, state the type of iteration illustrated in the algorithm above. Iteration is code repetition based on a condition which can be bounded on. I love that. All right. Which type of iteration is used in the first and foremost, identify what is the iteration and then tell me the type. Not seeing anything in the chat. What is the iteration used here? And which type is it? All right, Dukington for the win. So the while loop is the iteration using this question, and it is an unbounded iteration. Unbounded, we know that while and repeat until are classified as unbounded, and your bounded loop would be a for loop. The next part of the question now says, state how the loop in the algorithm above is expected to terminate. When would this algorithm stop? What was the condition? The condition says while z is less than 8. So what would cause this algorithm to stop? When does it print sum? What value would it be? When z is greater than 8. All right, something else I would add to bear rabbit. Bear rabbit with the full response. Full marks for bear rabbit. When z is greater than or equal to 8. Very good. All right, and the last part of this question now, which we'll need to see both, is to do a trace table. All right. So if we're doing a trace table, we can do it the easy way. It's 3 marks. I don't know. It depends on you and what you want to do. My advice would be to identify the variables and trace the variables. So we have Z as one variable, and we also have sum as a next variable. And then I would put output here. All right. So it says that we should trace 2. So Z, read Z, and it says sum equal 1. So let's say the user enters 5. Then it says we assign sum. Right, hold on, let me go back. Sum equal 1. The user entered 5, right? So it says while Z is less than 8. 5 is less than 8. So we're going to go inside the loop. So it says sum equals sum times Z minus 1. So Z is equal to 5. 5 minus 1 is 4. 4 times 1 is 4. No output would happen as yet because we're still within the loop, because we say read Z again. The user enters 3. We check now. Is 3 less than 8? Yes, it is. So here it is Z minus 1. So 3 minus 1, which is 2. 2 times sum is 2 times 4, which is now 8. All right, next one. The user enters 2. 2 is less than 8, so we're going to do the same thing again. So 2 minus 1 is 1. 1 times 8 is going to give you back 8. Right? Read the next value, which is 6. 6, so sum 6 minus 1 is 5. 5 times 8 is now 40. Now the user enters 12. 12 is greater than 8. So here we had no output, here we had no output, here we had no output, here we had no output. Now that the user entered 12, it means that we have to now go outside the loop. So we're going to terminate the loop and print sum. So the output would now be sum equal 40, and that would be the answer here. Now remember now, after the user enters, oh, it's lagging. Oh, after the user enters the 12, the system is going to terminate. So unless you run the system again, you're not going to enter 4. Let me know if that is clear. I'm not seeing anybody typing, so I'm going to assume that that part is fine. So the output would have been 40. All right, so we're now going to move into section C. And the first question looks at paradigms. Now, paradigms I know is one of those topics in computer science that not a lot of persons like. One, to teach, and two, students don't like the topic as well. Now we have a lot of programming paradigms, a lot. What they're used for, sometimes some persons have an, what is wrong with this thing? Issue remembering that part. All right, are you guys hearing me now? All right, good. So roughly I have 8 programming paradigms. You have lexical, you have syntax. Let me type that on the screen. All right, so we have lexical analysis, we have syntax analysis, we have semantic, we have intermediate code generation. We also have optimization. What am I spelling? Optimization. Also have code generator. We also have symbol resolution and execution. All right, explanation for any of these, any two here would be fine. Lexical, semantic, and syntax execution. I think that would resonate a lot with persons who are doing basic computer science. So with your lexical, basically you're scanning and you're dividing up your source code into tokens. That's all it does. Then now for syntax, it's basically going to do parsing. So it's going to ensure that the user would have followed the rules of said programming language. The semantic aspect now, it's semantics does not necessarily affect the overall, it doesn't stop your code from running, but it stops your code from running efficiently. Now, some languages will pick up on some semantic errors and basically give you some sort of feedback. So it verifies compatible variables and ensures that the language rules are followed as it relates to those. Convert to tokens, imperative and declarative as well. No, imperative and declarative would not be a, it's a part. Program translation. It's programming languages, not a translation process. All right. So those would be the different processes, and that was 5A. 5B asks for us to explain two good programming styles for 4 marks. Explain two ways in which good programming styles can be maintained when writing code. Anybody that wrote their IA? Modularity and efficiency. Efficiency would not be one. Modularity would be one. Breaking up your problems into. All right. Lanodel. Very good. Using comments and indentations. Use of indentations. Very good. So we have modularity that we spoke about. We have comments and indentations. White line is also a good programming practice. This is where you add the additional space and everything just don't line up. So indentation, white lines, meaningful variable names, and also using comments. Modularity, as Bucky said, I can add that to it. So basically where you take your problem and you break it up into smaller parts so that it is easy for you to basically address the issues. And any explanation for those would have been fine. Indentation makes your program readable. You explain that part so persons can understand the flow. What falls within an if statement? What falls within the loop? Indentation. White line is spacing, so basically it shows the different parts of meaningful variable names. So you're looking on, and persons who are reviewing your code will be able to identify what the variables are used for. Using comments as well would tie in with also variable names. So once persons are going through, or even for you as well, you would be able to easily remember what each fragment of code is for. And that was 4 marks. All right. This part, no, is very, very simple. I'm not sure if this was a something that threw off persons in the exam last year. All right, so this question asks for function. Now, CSEC gave almost 1.5 page for this. I read the question about 2 times because I was wondering why it is that seven marks I get 1.5 page. I don't know. I really don't know why them give so much lines. All right. So it says a formula for finding the volume of a rectangle base pyramid is given below. So they'll give you the formula because, we're not so, all of us is not so inclined. It's what Delano and Smith though. All right. So as I tell you, it's pretty simple though. I kid you not. I'm trying to zoom in. All right. Little bit too much. Things zoom out. All right. No. All right, good. So let's highlight the key parts. So it says write a function and it gives you the name of the function, pyramid volume, which accepts 3 parameters, right? And it gives you the base length, the width, and the height. It says now that it should calculate and return volume of rectangle, right? So we're volume right here. All right, so what is my solution? First thing you want to have is the data type for your function. Now we're calculating volume and we see a fraction right here. So it would be best to declare your function data type as either float or double. I'm using float. What is the function name that is given here? So you use back that which is given. Pyramid volume. Don't go about making up your own at this stage. Then now we have our bracket, and in our bracket we're going to have our parameters. Now it said that we have 3 parameters: the length, the width, and the height. Good. So what are we going to do now? Declare those. Now we don't know what the measurement will be, and again, just for safety, we're going to declare all of those as float. So I'm going to have float L, comma, that's one, float W, comma, and float H. Right? That right there marks. Right? Remember, you don't reach into the bottom part alone. So if I write this alone, you can get 2 marks, then we're good. Right? But we can go further. So we know that for our function going to have an opening bracket. And again, we just talked about good programming practice. So we're going to indent. So within this now, we're going to declare the 2 calculations. So right here, we see volume and we see area. So I am going to have float area, comma, float volume. Can you use one variable? Yes. I prefer to break up the question. All right. So now we're going to go into the calculation. So if you notice here for volume, I need area of base in it. So I'm going to calculate area first and then come back to calculating volume. So area equal, and it says length times width, semicolon at the end, right? Then now I'm going to calculate volume. Volume is equal now, and it gives us the formula. So we have 1/3, and we know that we're going to use a decimal and not the fraction. So that's 0.33 times area of base, which is area, times height, which is h, semicolon at the end. Oh, let me spell volume properly. Volume. All right, good. Now right here, we have calculated, we have the function name, we have the parameters, we have calculated, but we've not returned. So all you need to do now is have return volume, semicolon, and your closing bracket. That don't hard. It look like holy, but it don't hard. Float pyramid with me here now. Volume base, volume weight, volume height. All right, so Dell has that. But this now by itself would be incomplete. Yes, that is it. 7 marks, that is it. Nothing more and nothing less. As I said, the questions for section C, they're designed to cause confusion, but most of the time is one simple little 1-2 it want. Just follow the instructions and go through. When you're reading the question, highlight the important part so that you're not going over and rereading. Just read and highlight. What do they want? Some things you may miss, some things you may not miss. But at the end of the day, it's not like you're getting 0 for it because you're going to write the different parts that you pick up on. All right, can we move on now to the next question? All right, so that was question 5. Moving on to question 6. And question 6 is the last question. All right. So first part, question 6 is says differentiate between declarative and imperative. Now this is one of 6 popular questions them. I need to look back. I'm almost sure it was on 2021. Probably them don't put it back on 2023. But declarative and imperative. What's the difference here, guys? What's the difference between declarative and imperative programming languages? Anybody? All right, imperative, step by step. All right. 2 marks, step by step. And declarative. Let me see now. Step by step instructions. Imperative, Bucky said, you give the instructions on how to get the desired. I can work with that. Declarative tells the program what to do, while imperative how to do it. That is it. Sparks in here. So the declarative, it focuses on what the program should accomplish rather than how to achieve it. And the imperative specify the step-by-step instructions, which is going to control the flow of the code to get the desired result. But these answers are good. All right, so the next part of the question now. Hold on, let me snip the entire part for this question instead of having it here. Whoever the creator of snippet is, God bless you. Snipping tool. All right, let me come over to this side. All right, so this is a structures question. As I said, this question have 2 functions and a structure. I think that file coming this year. All right, so a vendor uses a C application to store data about vegetables that he sells. Each vegetable has, and as I say, when you're reading the question, highlight the part. So this now parts are the structures. What are we going to have inside our structure? We have ID and the data type is integer. Stop it. Then it says cost price, and cost price is floating point. Selling price, which is float, and we have quantity in stock, which is integer. All right, this up. CSEC don't tell you what you're supposed to do. All right. So when it is, so the question says write declaration for a C-struct veggie that can store the records for a given vegetable. Now let me tell you something, guys. You see, veggie and the first time veggie can make its appearance in a one question is the first year now that them break it up with them say, all right, do the declaration, do this part where it is that you're calling it in the body of the code. Normally you get one full thing that you write the full code for, right? So they broke it up this year. So we've seen a lot where it is that they've used reuse questions basically. All right. How do we go about declaring a structure? First thing we need to have is the word struct, followed by our structure name, and then did give us that. And it says that it is veggie, wait there, rec. Oh, see there. So veggie, rec, and we're using the capital, right? After that now, we're going to have our opening curly bracket. We just spoke about indentation. And you just define the variables as stated in the question. Data type first, int, ID, semicolon, marks, done. Next one, float. You don't even have to write out the whole cost price. CP, semicolon. Right? Come again, float, SP, semicolon. What's the next thing that them tell you? Quantity, which is integer. Integer, QTY, semicolon. And you close your last bracket with a semicolon. 2 marks. Two marks, that's no hard. That was not a hard question, was it? I prefer it like that as well, Smith, when they break it down. All right. Moving on to the next part now. So the next part, how do we reference the structure in the body in int main? Good. So I tell you what, we have two products, carrot and peas. All right. So for your 1 mark now, you are going to start back. So the first thing we write, struct, the name of our structure, which is veggie, and the two products that we have, carrot, semicolon, struct, veggie, and we're going to now have peas, semicolon, 1 mark. Pretty easy. All right, so what does the next part of the question ask for? All right, let's move this over. All right, so now it says now write C code to input data into the carrot structure. And you can make up your own prices. So you can use any value for these, right? So now we don't need structure, we don't need veggie anymore. We just need the reference. So it says we're doing it now for 1, which is carrot. So we type carrot. I think my system is tired, so it start lagging. Alright. I think it is ready for me now. Alright, carrot, dot. So once you put the dot, it's referencing what we have in the structure. So carrot dot ID equal, and we give it an ID number. So, and it must be of integer. So you can add no letter now because you declare it as an integer. You're not going to get the marks if your data type don't match what your value, if it doesn't match your value. So carrot again, dot, and you do it for each. CP equal $20.50. That's a floating point number, semicolon. Carrot dot selling price equal $50.40. Semicolon at the end again. Then now, so that's selling price and quantity again, carrot dot QTY equal, we have 10,000, and that is it for your 2 marks. As I said, and as Smith said, I would prefer that as well, Dale, if they give it like this. But they have been doing it for the last, I know they did it last year. Or yourself. Yes. And not the quantity, but the selling price and the cost price. I know they did it last year, but they have different sections that they do it in at different points. So there's one year that they did this kind of structure, but it was for section B for an algorithm. And I've seen it for function in section C, and I'm now seeing it for structure. So you can probably see something like that for file. You can never tell. Of course, you can come over here and shop there a bit. What you thinking? All right. So the next part now says, assume two VeggieRec structures, tomato and beans, are already loaded with data. Write C code to exchange the cost price values. This part now, think about you having 2 glasses of water, then full to the brim. All right, 1 glass with water, 1 glass with juice, and you want to change the containers. You need a third container. Good? So it is saying, let's say everything is basically declared as how it is supposed to be declared already. What? Dollar. All right. Sorry about that. Now, you have to have a temp, and that's what we're going to use. So we're going to take the cup of water and we're going to throw it in our next cup, right? Consider it like that. So here now, temp, which is my variable, equal tomato dot cost price, CP. I'm taking the price of the tomato and I'm adding it to a temporary file. Throwing the water into a next container. Now my water cup is empty. So I'm going to take my water cup, which is tomato.cp, and I'm going to throw the juice in it now, which is the bean, BEAN dot CP. Then I'm going to take the water that I had in the next container now and throw it in the next one. So bean dot CP equal 10. Each one should have a semicolon at the end. And that would have given you 3 marks. All right, how was this question? How was this question? We have one more, and then after that part, and we're finished. As I said, this paper was really an easy paper. I know that, like, if Darren got this paper, I know he would have had a field day with it. Yeah, not bad for real. All right, because I think some persons start dropping asleep. Let's move on to the last question. If you've had the time and go through the other past papers, I think you guys would have been okay. The content as well. So this one requires a little bit more thinking. So let us underline what we need to underline. So it says write a C function. The name of our function is total, which accepts a 10 value integer array as the parameter, and it gives you the variable and the values or the places. It says it should return a count of the numbers in the array that are less than 20. Pretty easy. It just requires a little bit of thought. And see, Smith, I'm going to show you now how this question is just reading it. That is the and understanding that which it is asking for. All right, let's take it step by step now. First thing we want to do is that we want to declare our function, right? So it's a write a function total, and we're accepting integers. So I'm going with int total. It has one parameter, and we put that in the bracket, and that parameter is of integer as well. And it gave you the name of the variable, which is number, and it gave you how many values it is holding, which is 10. All right, that never bad. We get that part? Let me see yes in the chat. We get that part. Understand that part and you tell me, and then we move on to the next part. Function data type, function name, function parameters. All right, one person, bear a bit. What about the others? All right, two of 23. All right. All right, moving on. So now we need to declare variables inside of our function. So I'm going to have count. So notice now that count is checking how many values are less than 20. So I need to initialize. Always initialize, right? To get marks for initializing. All right, that's that part now. We need a for loop to ensure that it checks 10 values. I'm going to have for open bracket, right? I can use any value here, so I'm going to use C equal 0, semicolon. Did I declare C? No. So I'm going to have int C equals 0, all right, good. Then I'm going to put the condition. C should now be less than 10. We're not putting equal sign because our starting value is 0. We're not putting the greater than sign. That is what I was supposed to say. Right. We're not putting the equal sign because our starting value for C is 0. If we started at 1, then it would be less than equal to 10. All right. Then now we have C++, which is the increment. So C should go up by 1. Close bracket. All right. So inside of our for loop, we now need to have an if statement because we're only counting the values that are now less than 20. So we have if open bracket, the variable, right, which is number. Oh. And the location, which is C. So guys, follow me now. C in the for loop is going to be your container. Let me show you. So we have a box. The box is divided into 10. Just imagine that this box is divided into 10. Good. The top part is going to hold the values. That's number. The bottom part is the index, which is the location, and that is C. So what this part is saying now is that create a storage location which should not pass 10. Good. In each location, I'm going to have different numbers. So 5, 25, 30, 6, 14, 20, etc. Those are numbered. Those are the values stored in the variable number. But what are their locations? So 5 is in location 0. 25 or 23, which one this looks like, is in location 1. 30 is in location 2. 6 is in location 3. 14 is in location 14. And 20 is in location 5. Etc., etc., etc. as you go along. Good? So this part is saying if number, which is 5, which is in location 0, which is what C is at right now. So when we check that in location, if that is, let me come back here now. If that is less than 20, close bracket, we have our curly bracket again. Only at this time should count increase because the condition would be true. The number is less than 20. So count is now going to be equal to count plus 1, semicolon. Right? So this part is going to continue looping until we get a value that is, or sorry, until we reach the last location, which is location 9, right? And after we reach location 9, because we would have read 10 values. So follow me. Here we have our loop, and we said that is this part. Here we're now telling the system number in whatever location, check it if it is less than 20. This one is less than 20, count is going to go up by 1. Come back up here, so it check the condition and say, all right, no, we don't reach 10 or we don't reach 9. So we have to continue checking. So count C is going to go up, count plus 1. So 0 plus 1 is going to move you now to location 1. Check location 1, which is 23 or 25, whichever one that looks like to you. But it is less than, it's not less than 20. So count is not going to increase, so count will remain at 1. Then now, C is going to increase to location 2. It's going to check it again, and it will continue checking until it reaches the last location. And after it reaches that location, the system should return count. And that's it for 5 marks. I'm not sure if I have to watch in delay. Oh, lagging on your side. Alright, no problem. So that would have been the solution for that part. And literally, that is the entire paper. So to wrap up, the only thing I have is to remind you guys about encoders, decoders, and modulators. I think that I'm sorry, multiplexers. I think that may come as well. It's been a while. I think encoders would have been out for a period. So encoders are also digital circuit combinational circuits. It has a set of inputs and a coded output, right? So normally you would have multiple lines of input and fewer lines of output. How do you know how many lines of output you're going to use the same 2 to the power of n? Good. And once it is that you understand encoders, then you know decoders, because decoders would be the opposite. So while it is that encoders have multiple lines of input and few lines of output, decoders have multiple lines of output and few lines of input. So all you need to draw is a rectangular box labeling the lines from 0 up to input I subscript 0, going right up to the amount based on what they tell you. And you do the same thing for your output 0 or O starting from 0. So that's your encoders and your decoders. Your multiplexers, a shortening for MUX, it's also a digital circuit which will have many input, but you will have one single line of output. Right? So if it is a 4-to-1 multiplexer, you're going to have 4 lines, a rectangular box again, 4 lines of input, 1 line of output, and you label your inside the box. MUX 4 times 1, MUX 8 times 1, MUX 16 times 1. Whatever it is that they give you to draw, you are going to label inside it. From on the left, where it is that your inputs are, you label your inputs from the bottom, moving upwards with your lines. So you'd have input 0, input 1, input 2, input 3. And then you have 1 line of output, which is F or Q, whichever one it is that you want to use there. Circuits for encoders and decoders. It wouldn't be, I've never seen it before. I don't know if 6 would want to be. I've never seen it. I've seen where it is that they've asked you to draw, they've asked you to explain. Um pretty much that. You're welcome, Dukinton. Alright, so that is it, guys. Wishing you all the best on your exams tomorrow. Just pace yourself, as I said. So we're going to section 1. And boy, I don't want to make no predictions, you know. And I think definitely though, if I'm supposed to make any, is that you'll see files in I think files is coming for um, section C. For section B, I can tell you. If you go through any set of paper, I can tell you, you know what is coming for section B. It's either a flowchart or they give you a question. And your question more than likely some voting something where persons are selecting options between orange, mango, and banana, between green, red, and white. Something along them line that them always use for for the algorithms, or they break it up where it is that they want it to do different things. Where you should, what would you initialize, what would be your input, what would be your output. So just read the questions and paste there. Touch search protectors, I would encourage power power protection. I think that is one, as well as the, let me look back on the syllabus. There's one that I wanted to cover back, So power protectors, your surge protectors, your voltage regulators, your uninterruptible power supplies, your UPS, that part. Um, where it is. All right. The instruction fetch, decode, and execute. Make sure you understand that as well. So for module one, as I tell you, they have multiple areas that they can pull questions from for there. Definitely you're going to get a binary question. One of the topic that we did not look at is floating points. So watch videos on floating points if you can, because I think floating points will come is one of their. They always have floating point questions in section one. I think I have questions on the channel where we've looked at floating points, so you can look up on that. So that would be my prediction. But I would say for the most part, maximize the points for section one and two, and then pace yourself into section C, because I know for sure that the questions have a way of holding persons back, or it put persons in a bind. But if you're struggling in section C, I just don't want you to think about completing a full question, but more so just writing on the parts that you know that they're asking for. Give them something. You know how to declare the function, you know how to declare the structure, you know how it is to declare a file, right? Ensure you know that f in terms of you writing to a file, right? You know that you must have a pointer for your file itself. So once it is that you write different segments of, while it is that you may not come up with the full marks or those section, you still come up with marks instead of like a blank thing. So go through, and I have faith in you guys. All who me not teach me have faith. You know, good. So all the best tomorrow. Get some rest. Put some rest in there because you will go in the exam and blank out. So rest and eat, and then you can do the whole study repeat thing. All right. All right. Good night. Good night. Good night again, and all the best. Ah, you're welcome.